It's springtime, and our thoughts turn to gardens. What better time than to look for ways to put a Raspberry Pi to good use? This week, let's rig up a soil moisture sensor to make sure our plants are getting enough water. Hi, I'm Mark Neiman Ross, and welcome to this week's edition of Raspberry Pi Weekly. Every week, we explore the Raspberry Pi and share useful tips. This project requires the connection of 4 parts: a moisture sensor, an MCP 3008 analog to digital converter, a 5-volt water pump, and a TIP31 transistor. That's a lot, but look back at previous Raspberry Pi sessions in this library. We've covered all of this before. Because we only have 5 minutes, refer to the handout for details on how to connect these parts. I'm using the soil sensor from Velleman. Stick it in the dirt, feed it 5 volts, and it returns an analog signal indicating the soil moisture. Of course, the Raspberry Pi doesn't have a native way to accept analog signals, so our first task is to implement analog to digital. I'll use a standard MCP 3008 A to D chip. Instructions and schematics for wiring the chip are in the example files. Finally, we're using a TIP31 transistor to control the 5-volt water pump. Connect power to the Raspberry Pi. You'll notice that the moisture sensor glows red if it's connected correctly. Don't forget to enable SPI with raspiconfig. Go to the interfaces, look for SPI enabled. If it's not enabled, you'll need to enable it now. Open up keepwatered.py from the example files. Let's take a quick look. In lines 1 through 4, we import libraries. And in lines 6 and 7, we define what pin we're going to use for the moisture sensor and what pin for the water pump. Starting at line 9, we define a Control-C handler. This turns off the water pump and exits gracefully if you hit Control-C. This is important so that the water pump isn't left running and using up all of the 5-volt battery. Starting at line 16 is the main loop. First, the loop prints a wait and then sleeps for 5 seconds. Then it prints check, indicates what time it is, and what the moisture sensor value is. If the moisture sensor is less than 0.1, the program prints pump and the moisture sensor. The water pump will turn on just for a brief period of time and then loop again. If the moisture is okay, our program only prints soil moisture is okay and then sleeps for another 5 seconds. You may want to change how long the water pump is on and how often this runs. Let's take a look and see how it works. Right now, our moisture sensor is indicating that the soil moisture is okay. So let's fool our system. I'm going to take the moisture sensor out of the ground. And you can see that our system has figured out that the moisture is not where it should be, and so it waters the plant. Now, here's a challenge. How could you modify this software so that it would check the plant every 5 minutes instead of every 5 seconds? Here's a hint. Did you watch the Raspberry Pi Weekly session on using cron with a Raspberry Pi? There are lots of parts to this project, but we've covered all of them in previous sessions. Be sure to watch those videos for details. Thanks for joining me for this episode of Raspberry Pi Weekly. Be sure to join the LinkedIn group and check out previous episodes on LinkedIn Learning. I'll see you next week with more Raspberry Pi adventures.